Hello all, this is John from EastCoastArmory.com, and I'm here today with a project update video for this 1/6 scale Armortek radio-controlled Panther Ausf.G. Since the last video update, work has been done to the model's upper deck, and the upper deck now is just about completed. In this video, we'll go over all the modifications and upgrades that were added to the upper deck of this model. The way the upper deck mounts to the lower hull was changed. On the Armortek model, the upper deck was designed to be permanently affixed to the body via small L brackets mounted throughout the upper hull. These L brackets were then designed to accommodate fasteners which, when tightened, would permanently affix the two pieces together, thus making them one unit. This design is a robust one. Unfortunately, with a tank like this, you want to get access into the interior, namely to get access to the batteries. After a few years, these 12-volt batteries will need to be replaced as they will not be able to hold their charge anymore. To go in and fish the batteries out from the large turret hatch is going to be very difficult. So to get around that, I designed a system that makes the top deck removable when the need comes to get access to the batteries. Along the edges of the plate, the detail welds were sculpted in via a two-part epoxy, like I do on all of my other 1/6 scale models. Now, because of the top deck is removable from the body, there's a very small, very slight little seam line that runs across where the two plates merge. This seam, unfortunately, has to remain because of the way the top deck disassembles from the body. This is, again, one of those balance acts that you have to do whenever you're building a radio control model. If you have to make a detail, however, you also have to make it accessible and functional. The seam is very small and very minute and will not be very visible once the model is fully painted and weathered. The new mounting system utilizes 4 bolts. There are 2 large Allen bolts like this one here on these 2 portions here of the model's upper deck. These 2 bolts pretty much hold the entire upper deck to the body. On the back, to secure the body to the upper deck, that is facilitated by 2 more smaller Allen bolts that are hidden over here and over here on the tank's detail. On the real components, on the real vehicle, there are 2 small retaining bolts that resemble much of Allen bolts. And they are in the center of these 2 pieces. On the kit original, it was very plain and these details were not present. I simply drilled them out on a drill press and went ahead and fabricated the wells for the 2 Allen screws. 2 Allen screws themselves act as both a detail element, as the real tank has something similar, but also act as a securing point which locks the rear deck here to the model's upper hull. We will go over that very shortly. To remove the upper deck, it's as follows. We first take our Allen wrench, insert into the bolt, and just simply loosen the bolt. This needs to be done to both of the large Allen bolts on either side of the upper deck. With the bolt removed, we will now go ahead and remove the 2 bolts that are on the rear deck. Simply insert the Allen wrench into the Allen screw and rotate. With the 4 bolts removed, the entire upper deck simply lifts off of the model as such. And with the top deck removed, we can see the revised mounting bracket system. Over here, to modify the mounting brackets, I simply altered the Armortek versions. Over here and over here, and parallel on the other side, are the stock Armortek L brackets, which go ahead and allow the top deck to be bolted to the hull. A similar setup is here on the back with these two yellow brackets here. The modification is that instead of having these brackets mount on the bolts from the top deck, I use these brackets to mount on the new mounting system. And we'll start with the back. The back, it's a steel plate that is about 1/8 of an inch thick. The steel plate has its holes drilled out for those two large canisters on the rear deck of the Panther, and holes that are drilled through it are tapped to accept the two Allen screws that are screwed into the top deck, thus securing the back. As for the side brackets, again, I utilize the two Armortek supplied fastener mounts. Only instead of mounting a big plate of sheet metal, I utilized a plate or an angle piece here made out of aluminum. The aluminum bracket here has two holes drilled into it. These two holes are also tapped to accept the threads of the Allen bolt that we have here. The original design was to utilize 4 bolts to retain the top deck to the hull. However, once I tried it in practice, I realized that the second bolt is not only really difficult to get to, it was not necessarily needed to keep the top deck to the hull. So that design was dropped, and the design only utilizes 2 large Allen bolts to do the job. Also, if we notice here in the rear portion of the model, several divots were cut into the aluminum for clearance. These divots are for clearance of the fasteners that were added to the rear engine plate, which we'll get to later on in this video. And here goes the underbelly of the top deck with the modified angle braces added. The braces run along the entire top deck of the upper hull. The reason for this is that it gives a lot more stability to the plate and mounts it more securely to the model. On the front portion here, we have 2 rubber discs. These discs were fabricated out of old burned out rubber molds, and the purpose of them are to squeeze into the front corners here of the upper hull, thus locking them in place. On the rear portion here of the deck, we have another piece of angle aluminum. This piece of angle aluminum is nothing more than a bulkhead, and it prevents the top deck from flexing due to the weight of the turret. On the kit original, there was a large, heavy steel laser cut bulkhead. The bulkhead itself is very strong and very durable. Unfortunately, because the deck needs to be removable, this plate was not going to be needed. This is because of the side plates here, the side angles are designed so that once the model is built, the top deck cannot be taken off. So instead of using the steel, I went ahead and used the aluminum angle. The aluminum angle gives you a lot of strength in that it still does the job in preventing the upper deck from warping. However, it's not only a lot lighter than the steel plate, than the steel bulkhead, but it's also a lot lower profile, so it will have an easier time fitting with the batteries in the way. To mount on all of these new brackets, new holes were drilled into the top deck, and all the parts are mounted on with countersunk fasteners. Both the holes for these fasteners as well as the holes for the original kit fasteners were plated or were covered up with the bodywork and sanded flush. No fasteners are visible from the top deck. The actual removal plate design that I have here with the 2 angle aluminum bars with the rubber stops, that design was actually borrowed from another model maker whose build post on the Armortek forum can be found on the link listed below. Because the top deck is removable, I had to design a quick disconnect jack for the fans that we have here in the back, as well as another quick jack design will be fabricated for the radio antenna, which will be mounted to the top deck as well. Before you can insert the top deck to the model, you will need to plug in these jacks. After the required jacks are plugged in, it is now time to reinsert the top deck. first line up the deck with the body. You line up the two rubber stops into the front portion here of the hull. Once the front is lined up, you simply just drop the back portion on as follows. The hull is now one piece and is now ready for the fasteners. Once you fasten the body to the top deck, you will no longer have to worry about the model's top deck wobbling on you, and you will only need to worry about removing this top deck when it comes time to change the battery. Before I'll get into the modifications made to the turret turning motor, I'll first talk about the brass turret bushing ring here. On all Armortek tanks, the turret mounts to the hull and it glides on this very intricately machined brass bushing ring. The ring itself is all made out of one-piece brass and is all machined to the proper shape and dimensions. The only thing that's not done to the brass ring is that it is not drilled and countersunk to be mounted to the body permanently. When mounting the ring, it is important to bolt it to the top deck to avoid a lot of headaches down the road. To do this, I simply drilled 4 holes on opposite locations of each other, and these holes were then countersunk to allow a countersink Allen wrench bolt here to be nice and flush, or even sink below where the turret turns. Keep in mind the turret needs to glide nice and smoothly and doesn't have to hit any obstructions. So if the bolts are flush or even recessed into the ring, it would be better mechanically. Also, the ring itself needs to be nice and smooth. The previous builder had a lot of paint overspray on this brass bushing here. All of that paint was removed and was either sanded flush or removed with chemicals. You want to have a nice, smooth surface on this ring to ensure a better, precise rotation of the turret. At this point in the build, I can now go ahead and mount on the turret rotation motor. If we recall from the previous video, the motor was hooked up to the appropriate jack and was tested via the radio. To mount in the rotation motor, the kit has 2 countersunk holes that are drilled into the top deck right over here underneath the turret. There are 2 simple bolts and nuts that hold the rotation motor together. Unfortunately, on this build, for some reason, these holes appear to be out of spec, and if you try to mount the motor into the lower hull, it will actually make contact with the sponson and the side wall as follows. Here, I'm trying to position the motor so that the mount holes line up with the ones on the top deck. As you can see, I can't. The motor is currently making contact with the side hull here, and if we notice, the top holes here are not lining up with the holes on the mount because of the motor hitting the hull. As for a better view, I have the motor, and let me try to line it up with the hull holes. As you can see, I can't. This is as far as I could push the motor in because it is making contact with the side wall. As you can see, the mount doesn't even come close to the holes that are on the top deck. This issue was very interesting in that I've never encountered a problem like this with my other Armortek builds. All of my other Armortek tanks, these holes line up almost perfectly with the rest of the tank, and there aren't any places where the parts can impact. As for why it's doing this, I don't really have much of an idea. Possibly the CAD program was slightly out of spec, or the motor was a little bit different than the one originally intended for the build. Regardless, to fix the issue was very simple, however, did require to take some measurements. To fix the issue, I simply, instead of mounting the motor on the kit design motor mounts over here on this side of the hull, I mounted it directly across and adjacent from those holes on this side of the hull. This portion here of the hull, there's really no interference with wires or electrical conduits, so it's a nice, simple spot to mount it. As for the hole's dimensions themselves, I simply took a tape measure and measured exactly where the holes were on this side, and simply just plotted them here. The holes were then center punched to make sure they're nice and accurate. They were drilled out, and then countersinks were mounted just like they were on the kit original. Be sure to also test the fit of the motor mount like follows. And as you can see, the holes line up perfectly with the motor mount as intended. To securely mount the motor mount to the upper deck plate, this is the way I like to do it. First, the motor mount itself is affixed via two M4 hex bolts. The bolts themselves are actually quite long and are obviously used to go through the upper plate, as well as the thick aluminum motor mount here that's affixed to the turret rotation motor. Simply insert it on as follows. Now, the way I like to mount it on is to really prevent the motor mount from twisting or rotating. You need to really affix it nice and firmly. For that, I like to use washers as well as lock washers. I simply put the washer on. I sandwich a lock washer in between, followed by another washer, and then the nut. This sandwiching effect really clamps down well on the mount. After you simply hand tighten the first one, do the same exact modification to the second. This is very important because if the pieces are not tightened all the way or good enough, you will have some wobble with the motor, which can affect the turret rotation. Again, it's one flat washer followed by a lock washer, which is then sandwiched by another flat washer. Which is then anchored by the nut. Once the pieces are just hand tightened on, it is then to tighten them with a ratchet and another wrench on the reverse side to keep the bolt from spinning. After the parts are tightened, it looks something like this. Once the bolts are tightened, you will see that there's absolutely no wobble with the motor mount. It is at this time we will put the upper deck back onto the model to test the turret rotation. If everything goes according to plan, we will then add a drop of thread lock to each of these bolts and give them one final little tug just to tighten them up further. To test the turret, we mount the upper deck to the hull again. Now the deck is just popped onto the body. It's not fixed in with any of the securing fasteners because they're not needed for this application. We then take the electrical cord for the turret rotation. This is the power cord for the motor. This is the power box turret rotation motor clip. Plug it together. We'll turn on the motor, or the end. We'll turn the tank on again first via the radio, and then the tank. As you can see, the motor spins, and we're now going to put the turret on and test the turret rotation with the motor. We'll grab the turret and simply mount it to the brass bearing, which in this case, it just sits directly on top. Now, if we notice, the turret is missing its roof, and I removed the gun barrel, which was mounted in the earlier scenes. That's because they are not needed for the purposes of this test. However, they will be mounted permanently as the build goes on. Okay, testing out the turret rotation. We can first turn on the radio, then the model, and let's test out the rotation. If everything was mounted properly, the turret should rotate smoothly. Okay, as you can see, it only turns one direction, but the motor is slipping in the reverse. That is because more than likely the gears are not meshing properly, which will need to be adjusted. Upon further inspection of the motor, it seems that the gear was not loose from the set screw. Instead, it was actually slipping on the small little bushing that we have here. It's hard to get into focus, but the way the gear is, it's comprised of two pieces. You have the gear, which is a turned gear stock, on top of a CNC'd little collar which grabs the spindle of the motor. Now what happened was that the gear was slipping on the little precise little bushing that was on the spindle. This is very rare for this to happen, and this is actually another first for me to experience this. Of the several Armorteks that I've built, I've never encountered an issue like this. If this issue is from the previous builder, I can't say. However, the issue was solved. To fix the issue, I first added a drop of Gorilla Glue to the spindle in the gear. The Gorilla Glue is a very strong bond and will grab the piece very firmly. In addition to the glue, I also staked the top portion here of the gear. The staking is a method of taking a chisel and a hammer and you cut or you smash a couple notches into the face here of the gear. What that does is that it expands the material and kind of locks the metal together. In addition to the glue and the chiseling of the staking, I also drilled a hole through the gear via a drill press. With a drill press, I drilled a hole directly through the gear, the sleeve, and the spindle, and inserted in a steel 1/16 of an inch pin. That pin is pushed all the way through and is flush with the base of the gear, so no burrs or anything could make contact with the turret turning gear. Also, the location where I did the pin is much lower than the turret turner gear. If we notice where the wear is, this is where the teeth mesh together on the motor and on the turret. The pin is far below that, so it will never make contact with it. However, just to play it safe, I went ahead and pushed the pin all the way through so that there's no burr sticking up. The pin will lock the whole spindle together as one piece and should alleviate all the spinning issue that I had previously. That, along with the staking and the glue, should solve the issue 100%. We will now install the motor to the upper deck and give it a second test run. We will now do our second test for the turret turner. Again, we first turn on the radio, like I mentioned always. Now we turn on the model. And let's see if the turret rotates. And it looks like a success.